Hi students, welcome to today's class. So today I am going to explain a very important topic. So based on that you are going to get some questions are also in your JEE mains examinations. Okay now. So let us see that topic. So the topic is rectangular hyperbola, or sometimes it is called as equilateral hyperbola also. Now what is that rectangular hyperbola? So let us see that hyperbola. So this is a, let us take this x-axis and it is a y-axis. So these are all called vertices A and A dash, and this is a transfer conjugate axis. Here A dash is called transverse axis, and B dash is called conjugate axis. Okay, C is called the center of the hyperbola. We know that the length of the transverse axis, that is A dash, is equal to 2A. The length of the conjugate axis is 2B. That we know that. If at all, is there any possibility of both A and B, both A and B are equal, both 2A is conjugate axis and transverse axis are both are equal? Yes, it is possible. There is a possibility is there. In that case, that type of hyperbola is called rectangular hyperbola. Okay now. So let us see the definition of this rectangular hyperbola. So the hyperbola in which the length of the transverse and conjugate axis are equal is called the rectangular hyperbola. So here what is the length of the transverse axis? So this is called transverse axis and it is conjugate axis. This is a transverse axis and it is conjugate axis. If these two are equal, that means 2A is equal to 2B, that implies A is equal to B. That means CA is equal to CB. This is A and it is B. Then that hyperbola is named as rectangular hyperbola. Otherwise, it is simply an hyperbola. Okay now, right. For this hyperbola, rectangular hyperbola, now what is, first of all, you should know what is eccentricity of the rectangular hyperbola and what is the equation of the rectangular hyperbola. Okay now, the first one is you have to know is eccentricity of the rectangular hyperbola. Okay now, so we know that for an hyperbola the eccentricity is root of a square plus b square by a square. Now it is already known that A is equal to B, therefore in place of A substitute B or in place of B substitute A. So nothing wrong in it. So therefore A square plus A square by A square. So this is equal to 2A square by A square. A square cancel, root 2. Therefore the eccentricity of the rectangular hyperbola is root 2. That is over. Now let us see the equation of the rectangular hyperbola. Equation we are going to see. What is the equation of the hyperbola? X square by A square minus y square by b square is equal to 1. Since A is equal to B, in place of B substitute A. So that is equal to x square by A square minus y square by A square is equal to 1. So multiply with, since A is not equal to 0, multiply with A is x square minus y square is equal to A square. Multiply with A square. So this is the equation of the rectangular hyperbola. Now we are going to see what are the equations of the what are the equations of the asymptotes. Okay now. So already we explained about asymptotes. So asymptotes are the tangents of the hyperbola which touch the hyperbola at infinity. Okay, so let us see the equations of the asymptotes. Okay now, welcome to this concept. Now we are going to see equations of the asymptotes. Now if it is a equation of the hyperbola of the form x square minus x square by a square minus y square by b square is equal to 1. Therefore, what are the equations of asymptotes? Asymptotes is given by y is equal to plus or minus b by ax. Y is equal to plus or minus b by ax, that we saw in the previous videos. Now here for rectangular hyperbola, so for rectangular hyperbola we have A is equal to B. So already we said that For rectangular hyperbola, the length of the transverse axis is equal to length of the conjugate axis. So, in place of when A is equal to B, what happens? B by A value is 1. Therefore, now for rectangular hyperbola, what is the equations of asymptotes? Y is equal to plus or minus x. These are the equations of the asymptotes of the hyperbola, rectangular hyperbola y is equal to plus or minus x. So, y is equal to plus or minus x means what? Y is equal to x and y is equal to minus x. We know that y is equal to x is a straight line passing through the origin and making 45 degrees with the x-axis. Why? Because here tan theta is equal to 1, therefore, theta is equal to 45 degrees. Therefore, this is a one asymptote, so making 45 degrees. Okay, now already we know that y is equal to minus x is a straight line passing through origin making 45 plus 1, 45 plus 90. So, 135 degrees with x-axis and passing through the, so this is a tangent. So, this is a tangent, it touches the infinity. So, this angle is actually, this angle is, so minus means 90 plus 45, 135 degrees. So, this is equal to total 135 degrees. That means what? This is 45 degrees. The negative direction, it is positive there, 45 degrees. So, from this clearly the angle between the asymptotes, is clearly 90 degrees. The angle between the asymptotes of the rectangular hyperbola is 90 degrees. Okay, now. So, from this we have to what the conclusion is. So, first of all, definition of rectangular hyperbola. What is the definition of rectangular hyperbola? In a hyperbola, if the length of the transverse axis is equal to length of the conjugate axis, then that hyperbola is called rectangular hyperbola. First thing. Second one is, what is the eccentricity of the rectangular hyperbola? Root 2. Third one is, what is the equation of the rectangular hyperbola? X square minus y square is equal to a square. Okay, now. And the fourth one is, what is the equations of asymptotes of the rectangular hyperbola? Y is equal to plus or minus x. And the fifth one is, what is the angle between the asymptotes of the rectangular hyperbola is 90 degrees. That means both are perpendicular to each other. Okay. Now, we are going to see here equations of the rectangular hyperbola is x square minus y square is equal to a square. Now, we are going to see another type of rectangular hyperbola whose equation is something different from x square minus y square is equal to a square. So, let us see that type of rectangular hyperbola. Dear students, now in this concept I am going to explain another form of equation of the rectangular hyperbola. So, what is the equation of the rectangular hyperbola is x square minus y square is equal to a square. So, here so this is a and here a dash and it is a b and it is a b dash. So, these are called transverse axis and it is conjugate axis. Okay, so both are perpendicular to each other, right? Clear. Now, what we are going to do is this transverse axis and conjugate axis I am rotating 45 degrees. Rotating 45 degrees in clockwise direction. Remember, without changing the origin, without changing the center of the hyperbola. Just in the first year course of our CBSE in mathematics or in the whatever be that, there we have transformation of axis, there we see the rotation of axis. Here I am rotating both the axis, how much degrees? 45 degrees. In which direction? Clockwise direction. Definitely the shape will be same, but the position of the hyperbola will change. So, it is something like there. So, this is equal to, so this will be the, and it is, okay now. So, this is so almost this is a and a dash and it is b and b dash. Okay now. Now, your, so this is, see here I rotated both transverse axis and conjugate axis in which direction? Clockwise direction. How much angle? 45 degrees, without changing the position of the center of the hyperbola. Okay, now just I rotated. Now this is also the rectangular hyperbola only. So here we are not changing the same. Here also the length of the this conjugate axis or the transverse axis and conjugate axis are equal, but the equation of the hyperbola will change. Rectangular hyperbola will change. Now the equation of the rectangular hyperbola is xy is equal to c square, where c square is equal to a square by 2. So here you see here x square minus y square is equal to a square in the original form. After rotating both the transverse and conjugate axis 45 degrees in the clockwise direction, now the transformed equation, there we know what is the original equation and transformed equation. The transformed equation is equal to xy is equal to c square. We can solve this, nothing wrong in it. So here we have a table. So using that table, so here angle of rotation is 45 degrees, minus 45 degrees, angle of rotation minus 45 degrees. After substituting, we will get that xy is equal to c square. This is also a second degree equation. Okay, now when this equation came, xy is equal to c square is came, but the center is same, 0, 0. The vertices will change. So previously the vertices are a, 0. This is minus a, 0. Now the vertices are a and a dash. The equations of the conjugate axis and transverse axis also will change. So how they change, what are the everything we are going to discuss now. Okay, so welcome back. So we are going to see the equation of the rectangular hyperbola of the form xy is equal to c square, where c square is equal to a square by 2, where a is the length of the either transverse axis or conjugate axis. Why? Because rectangular hyperbola, both length of the transverse axis and conjugate axis both are equal. Okay, now this blue line, so this is called rectangular hyperbola. Let us see all the parameters of that. Okay, now first thing is center. Center we are not changing. Center we are keeping as it is. That's why the center is 0, 0. The vertices are, it will be changed. So the vertices are plus or minus c, plus or minus c. So the vertices will be plus or minus c, plus or minus c. That means c, c minus c will be there. So that is the, so otherwise you can take if it is your hyperbola is in this form, conjugate form, then if you rotate this, then the vertices will come in which place we will get, it will come in the first and third quadrant. That means, for example, if your hyperbola is like this, conjugate hyperbola is this. Okay, so if you rotate the both x-axis and y-axis in the clockwise direction 45 degrees, then the vertices of the rectangular hyperbola will be in the first and third quadrant. That's why there are 4 positions will be there. Okay, right. Now coming to the foci. Foci is also plus or minus root 2, c. Here plus or minus root 2, c. Now the axis will be y is equal to x, y is equal to minus x. That's why obviously, so this is the axis of this. So this is called transverse axis and it is conjugate axis. So the conjugate axis is nothing but y is equal to minus x, and this transverse axis is nothing but y is equal to x. When these are transverse and conjugate axis, your original x-axis and y-axis will act as asymptotes. Those are equations of the asymptotes is x is equal to 0, y is equal to 0. That means these two things will be reversed for the original hyperbola and this rectangular hyperbola. Both will be rectangular hyperbola of that form and this form. Okay, so next one, equation of the tangent. So this is everybody knows, wherever x is there, so we will substitute x1 and y is there, y1 we will substitute. Okay, so that so here already we know that in place of x we will substitute that x plus x1 by 2 and y plus y1 by 2 is equal to c square. So if you simplify that, and you will get that answer. Okay now. Alright, again 2c square, again x into y, xy is equal to c square. Then again here already c square is there. So that will be the equation. Okay now. And again, so the equation of the normal will be x1 minus y1 is equal to x1 square minus y1 square. This is the equation of the tangent and equation of the normal. Okay now. Right. So some more topics are there regarding this rectangular hyperbola. So let us see that. Welcome back. So let us see some more concept regarding rectangular hyperbola of the form xy is equal to c square, where c square is equal to a square by 2. The first one is the parametric equation. So for every conic, so there will be parametric equations. What are the parametric equations of this conic? Xy is equal to c square. So this is x is equal to ct, y is equal to c by t. Substitute here. In place of x, substitute ct, in place of y, substitute c by t. Tt will cancel, c square is equal to c square. So those are the parametric equations. So next one, what is the equation of the tangent at t? That means so the parametric point will be ct comma c by t. Ct comma c by t. That is the parametric point. This is denoted as small t. Okay now. So the parametric, the equation of the tangent at t is x plus yt square minus 2ct is equal to 0. X plus yt square minus 2ct is equal to 0. That is the equation of the tangent at t. The next one is equation of the normal at t is xt cube minus yt is equal to c times t to the power of 4 minus 1. So this is the equation of the normal at t. So normal at t1 meets the curve again at t2. So for example, if a tangent is there, if it touches the curve at only one point, if it is a normal, definitely it intersects the again at another point. So for example, this is a conjugate point. So this is a normal t1, definitely it will passes through the another point, let us call it as a t2. Then what the relation between t1 and t2 is? t1 cube into t2 is equal to minus 1. t1 cube into t2 is equal to minus 1. That is the relation between t1 and t2. Okay now. So next one, eccentricity will be same. Eccentricity will be same. Why? Because here, since we are saying a rectangular hyperbola, it is another form. Xy is equal to c square is another form, but the basic definition is a is equal to b. So the eccentricity is equal to root 2 and the length of the lattice rectum is 2 root 2 c. Okay now, right. Next one, the hyperbola, for every hyperbola, so is it, even though it is a rectangular hyperbola, it will has a conjugate hyperbola. That means transverse axis act as a conjugate axis and conjugate axis acts as a transverse axis. Then the hyperbola conjugate to xy is equal to c square is xy is equal to minus c square. The conjugate hyperbola of xy is equal to c square is xy is equal to minus c square. Okay now. Now next both are these x square minus y square is equal to a square and xy is equal to c square. Both those rectangular hyperbolas are cut each other orthogonally. That means the angle between those two curves is 90 degrees. Okay now, right. So the equation of the hyperbola having x is equal to alpha and y is equal to beta as asymptotes is x minus alpha into x minus beta is equal to k square. So for this equation of the hyperbola having x is equal to alpha, y is equal to beta. So previously x is equal to 0, y is equal to 0 are the asymptotes. Now if it is asymptotes are x is equal to alpha, y is equal to beta, that means what? X is equal to alpha is a line parallel to y axis, y is equal to beta is a line parallel to x axis and beta units away from x axis. Then the equation of the equation of the hyperbola is x minus alpha into x minus alpha into y minus beta. This is a y minus beta is equal to k square. Okay now. So these are the few topics that we are discussed here. Now I am going to explain very important topics that is very useful. That is equation of the hyperbola, equations of the directrix, eccentricities, asymptotes, and the equation of the conjugate axis. What are the difference between these three? Let us discuss that. Dear students, welcome to this concept. So very interesting concept this is. Relation between the equations of the hyperbola, asymptotes, and the equation of the asymptotes and the equation of the conjugate hyperbola. First of all, what is the equation of hyperbola? Hyperbola equation is x square by a square minus y square by b square is equal to 1. Everybody knows that. What are the equations of asymptotes? So the equations of the asymptotes, we know that this is equal to y is equal to plus or minus b by ax. So if you bring one side and if you multiply the equation of the pair of asymptotes. So to be frankly speaking, is equation of the pair of asymptotes will be x square by a square minus y square by b square is equal to 0. Why? Because this asymptotes passes through the origin. Okay, now. What is the equation of the conjugate hyperbola? What is the equation of the conjugate hyperbola? X square by a square minus y square by b square is equal to minus 1. Equation of the conjugate hyperbola is x square by a square minus y square by b square is equal to minus 1. That we know that. Why? Because here we interchanged the transverse axis into conjugate axis and conjugate axis into transverse axis. That is called conjugate hyperbola. Already we discussed. Now see the equations. So if you observe, the right hand side parts are equal for all this right hand side. X square by a square minus y square by b square, x square by a square minus y square by b square, x square by a square. So right hand side parts are equal. So what about left hand side part? So here you have got 1, here you got 0 and you have got minus 1. So if you observe, we can say a statement that the equations of the hyperbola, asymptotes and conjugate, they are differ by a constant term only. We can strongly say that they are differ by constant term only. That is the first statement that we have to know. The second one is, if you observe the constants also, how they are differ. See here what is the difference here? Here the difference is 1. The same difference is there from this first, call it as a first equation, second equation, third equation. Whatever may be the difference here, what is the difference here? 1 to 0, again 0 to minus 1. The differences are same. 1 to 0, 0 to minus 1. For example, if it here 4, if it is 0, then it should be minus 4. Understand? Understand. So next one, if it is some, for example, minus 4, it is 0, this should be 4. So whatever may be the difference between the first equation and second equation, the same difference should be maintained from second to third. That is the very important point to be noted. Okay, now. So based on this, we have a very small problem I am going to discuss. It's a very interesting problem. So if you can do that problem, you can understand this concept very well. Okay, now. So let us see the problem. Welcome back here. So we are going to see a problem here so that you can understand the concept that we discussed earlier. Okay. So the question is, find the equations of asymptotes and conjugate hyperbola. Equations of asymptotes and conjugate hyperbola of the hyperbola 3x square minus 5xy minus 2y square plus 5x plus 11y minus 8 is equal to 0. So already we discussed this, once again I am telling. So equation of the hyperbola is x square by a square minus y by square is equal to 1. So this is a hyperbola. Asymptotes, x square by a square minus y square by b square is equal to 0. Conjugate hyperbola, x square by a square minus y square by b square is equal to minus 1. Same difference should be maintained. Same difference should be maintained. Okay, now, right. Now already we know that the equations of the hyperbola and conjugate hyperbola, they differ, hyperbola and asymptotes, they differ by a constant term only. So here what is the constant term here? Minus 8. So the difference will be only in minus 8 only. So then what is the equation of the asymptotes? Asymptotes equation is 3x square minus 5xy minus 2y square plus 5x plus 11y plus c is equal to 0. So the equations differ by constant term. Now what are asymptotes? Asymptotes nothing but a pair of straight lines. A pair of straight lines. Asymptotes are nothing but a pair of straight lines, intersecting lines. Okay now. So if this equation, if this is a general second degree equation, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, to represent say a pair of straight lines, we have a condition. What is that condition we have? So we have the condition is ABC plus 2fgh minus AF square minus BG square minus CH square is equal to 0. That condition we have in the pair of straight lines chapter. So substitute all the values here. So this is a AX square plus 2HXY plus BY square plus 2GX plus 2FY plus C is equal to 0. Here A value is 3, B value is minus 2, C value is C only, 2 into. F value is 11 by 2, G value is 5 by 2, H value is minus 5 by 2, minus AF square. A means 3, F means 11 by 2 whole square minus B. B is equal to how much? Minus 2. Minus 2. B G square. G means how much here? 5 by 2. 2gx minus, so this is G is 5 by 2. 5 by 2 whole square minus CH square. C is C. H is equal to how much? Minus 5 by 2. So this is minus 5 by 2 whole square is equal to 0. So if you solve this, you will get a, so try to solve it, you will get C value is equal to minus 12. C value is equal to minus 12. So try to solve it. So therefore, equations of the asymptotes. Now what are the equations of the asymptotes? So the equations of the asymptotes is 3x square minus 5xy minus 2y square plus 5x plus 11y minus 12 is equal to 0. Understand here? Equations of the asymptotes. See here, what is the equation of the hyperbola? Minus 8. Equation of the asymptotes? Minus 12. So here 1, 0. Next, what is the difference we have to get? Same minus 1. 1, 0, minus 1. So therefore, equation of the conjugate hyperbola. So this is given by the formula. So this is a 3x square minus 5xy minus 2y square plus 5x plus 11y. See here, minus 8, minus 12, minus 60. Difference 4. So minus 8, minus 12. Difference is equal to how much? 4. So therefore, minus 12, minus 16 also difference should be 4. That's why here minus 8, minus 12, minus 60. Understand this? Minus 8, 1, 0, minus 1. Like that. Minus 8, minus 12, minus 16. So here difference is 4. Here also should be difference 4. Understand this? So like that we have to find out. So given a equation of the hyperbola. So this is the method of finding equation of the asymptotes and equation of the conjugate hyperbola. Okay na? So dear students, I hope that you enjoyed today's class regarding this conjugate hyperbola. Okay. So tomorrow with some more concepts I will stand before you. Until then, all the best.